Okay, so this video is just going to be a few quick examples of how to work through and represent solutions to absolute value equations. So first example right here, this number one that I circled. First thing you're going to always want to try and do is get the absolute value expression, in this case, the absolute value of x minus 2. Try to get that by itself. Try to isolate that, okay? So what we're going to want to do is add 5 to both sides, right, to get rid of this minus 5. Come over here where I have more room. Okay, and once we have this, this is where we end up with, we branch out into two possibilities for what x can be, right? So we're going to end up with either x minus 2 equals 14 or negative x minus 2 is equal to 14. Okay, and the reason for that, the easiest way I can motivate it, let's pretend, let's use a different letter so we're not really related to this problem. Let's use y. So let's say the absolute value of y is 4, right? Well, there's two numbers for which this is true. Okay, if I've got a number line and I say what two numbers have an absolute value of 4 or a magnitude of 4, right? There's not just one that does. Okay, there's two numbers that are that distance from 0, namely positive 4 or negative 4. Okay, so that right there means that y here is equal to 4 or negative 4. So we have to apply that same line of reasoning over here in our slightly more complicated example. Right? So once we get to this point here, where the absolute value expression is by itself, we have that duality. Okay? So let's start with this first one. So I don't need these parentheses. I just put them there to illustrate a point. You know, positive representation of this magnitude and the negative representation of this magnitude. So then we have x minus 2 equals 14. Well, that just means x is 16. Or multiply both sides here by negative 1. And we end up with just positive x minus 2 equals negative 14 now. Add 2 to both sides. So x equals 16 or x equals negative 12, right? And we're told to also represent the solution graphically. So we can go ahead and do that. So I know 16 is going to be here. We'll say negative 12 is here. And 0 is going to be somewhere in between. It's going to be closer to the negative 12 just because negative 12 has a smaller magnitude, right? And those would be my two solutions. Okay, and then to check our work, we can just plug back into this guy here. If I plug in either one of these, I should get an absolute value of 14. Well, let's see if that's the case. 16 minus 2's absolute value. Well, duh, 16 minus 2 is 14, and positive 14 has a magnitude of 14, right? Or if I do negative 12 minus 2's absolute value, well, that's going to be absolute value of negative 14, which I know also has a magnitude of just 14. Okay, so we see that both of those are correct. So let's move on to the next example for this video. As soon as I'm done erasing, there's got to be a more efficient way for me to do this. Okay, so here again, what we're trying to do is get this absolute value function by itself. We're trying to isolate it so that we can break it out into that, dual solution set, right? So what we're going to want to do is we're going to pretend that we've got 2a minus 8, where all of this right here is like a. Well, how would we do that? Well, we would do plus 8 and then divide by 2, and that's exactly what I'm going to do here. So I'm going to add 8. That leaves me with 2 times our absolute value expression is equal to 4. Then I'm going to divide by 2. Okay, and now I'm to the point where I'm going to do my OR statement, right? So positive x plus 1 equals 2, or negative x plus 1 equals 2. So this one's simple enough. I'm just going to subtract 1 from both sides on this one, and x equals 1. Or I'm going to go ahead and multiply by negative 1 on both sides. So times negative 1 times negative 1, right? That's going to give me positive x plus 1 equals negative 2 now. Then I'm going to subtract 1 from both sides. So now I have x equals negative 3. And those are my two solutions. Graphically, again, going to look like this. So 1, negative 3, 0 is going to be closer to the 1, of course. And I'll just put 2 dots here to represent my two solutions, and I've got it. So that's how I would show it, geometrically. Okay, and then let's plug back in, make sure that this works. I'm going to use this expression here, or equation rather here. It's going to be quicker. So is it true to say negative 3 plus 1's absolute value is going to be equal to 2? Well, yes, it is. Negative 3 plus 1 is going to give me negative 2. Negative 2 has a same magnitude as just 2. If I go ahead and try my other solution, which was, what was it, 1? So x plus 1, right? So 1 plus 1, well, no duh. That still is going to have an absolute value of magnitude of 2. Okay, so I know those are both correct. And one more example for this video, and we'll call it good. So this one's slightly more complicated, I guess, but not really. So we see we've got a fraction. There's two ways to go about it. I've told y'all already that you can get rid of fractions just by multiplying by the denominator. We don't need to do anything that fancy just yet, just because it's real easy to get rid of this plus 4 by just doing minus 4. Okay, so now we're here. X minus 3, the absolute value of that, all divided by 2, is equal to 0. And then we see we can just multiply by 2 on both sides. And here we are. X minus 3's absolute value equals 0. So this is where we split off into our OR statement and come up here because I ran out of room. So I'm going to say positive x minus 3 equals 0, or negative x minus 3 equals 0. So here on the left, well, we know x is just going to be 3, right? We just add 3 to both sides, simple enough. Here, multiply by negative 1 on both sides. We end up with positive x minus 3 equals, well, negative 1 times 0 is still 0, right? And I'll go ahead and show the steps so I don't confuse anyone. So times negative 1 on both sides. So that just makes that become a positive. Then we add 3 to both sides, and we see that we get the same solution both times, right? So for this one, we only have one solution, right? So our one solution is just positive 3 and only positive 3. And if we plug back in, so I'm going to plug it back into this guy here. I'm going to say, we know x is 3, so 3 minus 3, does that have an absolute value of 0? And well, duh, 3 minus 3 is 0. And there's only one way to really get that. Okay, so that does it for this video. Not too complicated on these absolute value equations. Just make sure, be careful with your minuses. But the equations are a lot easier to mess with than what I'm fixing to do the next video on, which is the inequalities. But like always, if you need anything else, shoot me an email. Otherwise, you know where to find me. Goodbye.